Okay, we have a short video now on troubleshooting K-Control, okay? K-Control, not the rotomolding process, troubleshooting the equipment that you've got installed. So, how can we best get to a solution if we've got a problem with our K-Control? Number one, define the problem. I have experienced so many times where we have customers contact us. We've got a problem with the system, it's not working. I have traveled many miles to solve these problems only to arrive and find it something very simple. Okay, batteries needed changed, receiver unit was not switched on. So simple things like that are a given to test. So define the problem and be as specific as you can. Is the problem that you're not getting radio communications? Is there a problem that the thermocouple signals are not coming through? Is there a problem with the software communications in terms of integrating with the machine? So some of the very simple things that you can do to help define that is to take 5 minutes and talk with the people who have alarmed a problem and try and write it down as much as you can. It's impossible for me to help if I get an email saying we have a problem, it's not working. So please try and help us as best you can so that we can help you. So define the problem. What is the problem? I cannot stress that enough. Which area is involved? To help you try and define that problem, let's look at the different areas that we're most likely, the top four if you like, that we're most likely to find a problem in. Okay, so number one, the thermocouples. Most unexpected hiccups are caused by thermocouples, and they can be very difficult to spot until it's too late and the arm has stopped the oven too late or stopped the oven too early, as most often happens. So why is that? Humans, that is the single biggest reason for failed thermocouples. A thermocouple is just two pieces of wire welded together at the tip. And if there's a failure, often what happens is either one of those wires breaks and you get an open circuit in the thermocouple, which should alarm the machine to say we've got an open circuit. The other biggest, most difficult problem to solve or to identify is if there's a short circuit between the two wires before it gets to the tip where it measures the temperature. If there's a short circuit in the plug or in the cable or in the slip rings, then what happens is you still get a temperature reading coming through. It looks as if it's fine. How do we know it's not the correct temperature? Through experience of knowing what the curves should look like and to know if they go outside the boundaries that we're expecting them to be in. That is an advanced piece of software which requires PC software help. It's very difficult to have that kind of software in a PLC. Okay, PLCs generally are not advanced or big enough in memory to provide that kind of feedback. We're working on something like that with our K-Cord software. So the easiest way you can fix an issue like that is to swap out the thermocouple. Don't try and fix it, swap it out, red tag it, set it aside, send it back to us and we can investigate and find out where it's failing. Okay. So thermocouples are the single biggest cause of malfunction in the system. There are some things that we can do to prevent that happening in the machine. That requires working together with the machinery manufacturer very closely. 493K's equipment is all third party as far as the machinery supplier is concerned. So we rely on our good relationships with machinery manufacturers to ensure that they can follow and fulfill the requirements for troubleshooting thermocouples. The next issue often found is brushes. So if we drop a channel altogether, it could go open circuit. Often it goes open circuit, no thermocouple attached because a brush is disengaged from the system. Change the brushes. If you are maintaining the slip ring itself regularly, making sure nuts and bolts are tightened, plates are parallel, the brushes have not been worn away too low, then you don't really have a problem with we have not found problems with brushes. Okay, this is 10 years developed. Okay, so issues are if the system is not maintained. The other cause for a lot of for problems with brushes would be if someone strikes the slip ring with a forklift truck with a mold dropping on it. The brushes could crack inside. There is not really an awful lot we can do about that except to train the operators to highlight the significance and the importance of taking care of the slip ring disc. Okay, so brushes. The other area within these two here, and in fact the third, is where cables are moving. And if cables are moving, they will degrade. They will degrade and either fracture, but more commonly they degrade, break down the insulation, and then touch. Okay, so that is another thing to look out for. So if you have thermocouples coming down into the mold or into the vent pipe at the top, make sure they're not flopping about as the mold is rotating, but secure them to the framework. And there are a plethora of sockets and plugs and adapters that we can supply for you to connect and integrate these thermocouples into your mold more securely. Through arm cable. That's the cable that runs from the back of the arm where the radios are to the slip ring. What can go wrong with it? Not really a lot can go wrong with that. The two biggest reasons of degradation or failure are one, degradation of the insulation, breakdown of the insulation, and two, crashing into it or breaking it, hitting the cable with again a mold, a fork truck, an operator working. The mold or the oven and the arm crash, something like that there. So why does that wire degrade over time? If it's installed correctly, inside a pipe work and it's completely sealed from the back to the front, there should, and it's not, that cable is fixed to the arm, then there should be no movement of that cable inside the arm, and therefore that should significantly reduce degradation of the embrittled glass fiber around the wire. Ensure that there are no exposed parts of the wire from the back to the front of the arm. And at the back of the arm where it goes into the radio, make sure that wire is coiled around the radio and secured with cable ties. If you cool with water, it is essential that water does not get touching that wire. Okay, it'll be fine for the first month or two, but if repetitive water is hitting that cable, it breaks the glass fiber insulation down. We haven't found any insulation that's going to withstand the high oven temperatures in rotational molding just yet. So take care of your through arm cable. This is all common sense, and this is all good stuff that can enable you to keep on top of troubleshooting your K-Control. The final one is machine integration. That's the hardest one for us to help with because we cannot get inside the machine to fix it. So we rely on the good relations that we have with our machinery manufacturers to identify and solve problems like that. What are the main kinds of problems that we see with machine integration? What the issues that you would see would be an arm coming out of the oven prematurely, usually prematurely, coming out of a cooling bay prematurely. And why is that? If there is a failure in the thermocouples, which is the top reason for failure in the system, if there's a caused by humans, if there's a failure in the thermocouples, it's usually because the two legs of the thermocouples have shorted out. And they're measuring the temperature at that point where they short out, not at the tip inside the mold, but where they have shorted out down the cable somewhere. Where is that cable going to be? It's going to be in the oven. So where they short out in the oven, they will measure oven temperature. The machine integration control basically looks at the temperatures coming in from K-Control, boom, boom, every 2 seconds. And it says, what temperature are you telling me you're at? We need the machine integration to be smart enough to be able to say, I'm expecting this, I'm expecting this, I'm expecting this, oh, I'm not expecting this. Discard that data. And if after a period of receiving that data, it's still coming back high, then the machine should default to a time-based cycle. And that time-based cycle should be a minimum time that the mold must be in the oven. A minimum time, not a maximum time, but a minimum time. Why a minimum time? Because again, as I already said, when the thermocouple is short, it faults to a high temperature. So the chances are that if you're going to fail, you're going to fail by taking it out of the oven prematurely. Okay. So in the cooling side, if it fails, it's going to also bring it out prematurely because it's cooling down. You're looking for the temperature to fall to 100, 110, 90, whatever you have decided is best for your process. It's shorted, it's measuring the ambient temperature, it has dropped below the 110, the machine says cycle is finished. But we need to compare the temperature with what the time should be. Not precisely, because we want to operate on temperature, but we should say, you know, take it out of the cooling bay when you're at 100 degrees C, provided the time you've been in there is greater than the expected cycle time of the part. Okay, so we're letting K-Control, as it were, operate within a band from the minimum cycle, the fail-safe cycle time, to a period above that time. Okay, so that is what you can. That's the main issue with machine integration that we have. In the beginning, we had a lot of problems with averaging of the components. Averaging of the data coming from the slip ring. If there was a spike once every 20 seconds, which is to be expected in a mechanical rotating device, you're going to get spikes, you know, but we're taking the temperature every 2 seconds, so we should be able to account for that. Okay, so what we do in our K-Cord software is we take the data every 2 seconds and we look for points that are too high or too low than the average, and we remove those altogether, and then we have ourselves a much smoother trace. Okay, and that smooth trace can be averaged over maybe five readings, 10 seconds, and that data can be provided to the machine. That is if the machine is not able to perform those kind of averaging functions. That was a big issue at the beginning when there was a learning curve amongst the machinery suppliers, but most of them have solved that problem now. So you shouldn't have too many issues with machine integration. Other issues that you may have with machine integration could be plugs not connected to the receiver not being switched on, fuses have gone, batteries are dead in the transmitter, things like that there. As I said in the introduction, what you've got is a thermometer. Excuse me. You've got a thermometer. It's a very simple thing that it does. The task that it completes is quite straightforward. It measures the temperature and it gives it to your machine. How we do that is 10 to 15 years of development, making sure that we have low spikes, robustness of the steel components. They're 10 millimeters thick stainless steel. Okay, if we make it 20 millimeters thick, then molders start to complain about the weight of it and the motor's turning the arm. So we're trying to get a balance here. So it's a compromise. It's a compromise between us making something 25 millimeters thick so that your operators can't break it, but and not making it too thin that it's light and the machinery suppliers are happy about the lightness. So we've got it in between. But what we need our K-Control customers to do is to treat the K-Control slip ring with a certain amount of respect. It cannot be hit with hammers. It cannot be hit with fork trucks. It cannot be hit with molds. Okay, so it's an expensive thermometer and should be treated as such. So Those are the main areas of K-Control troubleshooting. And I suspect that when you start off using K-Control over the first few months, that your main issues are going to be thermocouples and machine integration. So maybe something is not clear between 493K and your preferred machinery manufacturer. But we will work with you to find out what those problems are and offer suggestions to the machinery supplier. The system as a whole, you stand the best chance of not having these issues if you have training for your operators and you have a regular maintenance schedule. And the most important maintenance schedule is checking your thermocouples are good. Yeah, you can do this by plugging them in. Yeah, taking a hot air torch. Yeah, not a flame. It's better for the thermocouple with a hot air gun, and holding it on the tip of the thermocouple and watching that temperature rise on the machine software, or even better, the K-Cord software, because we can extract that from the laptop easily. We can analyze that data more easily, and so on. So K-Cord software certainly it would be a must for troubleshooting, okay, and checking the system. Take that hot air gun and run it down the full length of the thermocouple. And what that will do, it will raise the temperature along the thermocouple wire. And if there are any short circuits there, your temperature will rise, and that will identify a fault in that thermocouple. And most of them, I say, are at the junctions where the cable of the thermocouple goes into the socket or the plug, and where the cable of the thermocouple goes into the back of the probe itself. Okay, so that's why on our production probes we have gone to great lengths to ensure there is good connections at the probe side and good connections at the plug. It's important also that you tell your operators when they're removing that thermocouple from the slip ring not to pull it with the cable. Yeah, that's a very important. And likewise, removing the probe from the mold, don't pull it with the cable. Use the handles on each end to pull off. Okay, and if you don't have handles on your thermocouples, we can supply those. That's simple. Once you troubleshoot, once you've found your problem, the most important thing to prevent it from happening again is to decide what caused it and take affirmative action to train your guys to avoid this in future. And if it's something we can do to help, then of course you contact us and we can talk about that and see how we can help. So K-Control troubleshooting, that kind of covers the main issues. For damage, for breakages, for crashing, that kind of thing, it's clear that part will need replaced, that you need to fix something, then that should be done. And we've all got spare parts in stock for next day dispatch. So I hope that was of value. If there's any questions you have, of course, just send them off to ourselves at 493K, office at 493K will find its way to me directly. So that is the video on troubleshooting. Thank you.